Hello, and welcome to the Physics of Sports. My name is Rachit,
And I'm David.
and today we will be talking about the physics of football.
Today we're going to break down the physics of football into four categories: kinematics, kinetics, momentum, and energy.
So let's get started. In football, there are various kinematic components that can be found. When a running back runs for a touchdown, this is kinematics. When an offensive player gets sacked, this is kinematics. In general, kinematics refers to the study of properties of motion, position, velocity, and acceleration. Let's take a scenario to analyze this. Let's say a running back starts from rest position and accelerates to a speed of 5.6 meters a second in 4 seconds after receiving the ball. What would be his acceleration? For this question, we can use the formula acceleration is equal to the change in velocity over the change in time. We know that the initial velocity is 0 meters a second and the final velocity is 5.6 meters a second. We also know that our change in time is 4 seconds. So easy, we can plug these values into our equation to find his acceleration. His acceleration would be 1.4 meters a second squared. In this problem, we touched on many kinematic components. We talked about velocity, we talked about time, and we found the acceleration. Furthermore, we can use these equations to find many other variables related to kinematics. Now that we've touched on kinematics, let's move on to kinetics. What is kinetics? Kinetics is a branch of physics that studies the relationship between the motion of bodies and its causes, mainly forces. In football, there are forces for different situations. Here, we have a running back. As you can see, he is juking. To move upfield, he pushes against the turf, and the turf applies an equal and opposite force on him. This is an example of Newton's third law. The second force that is present is the force of friction between his foot and the turf. Friction is an important factor in running being able to change direction. The applied force and the frictional force together must stop the motion. The force required to stop him is the product of his mass and acceleration. This can be related to Newton's second law, which states that the net force of an object is the product of its mass and acceleration.
Momentum refers to the quality of motion an object has. Momentum can be defined as mass in motion. All objects have mass, so if an object is in motion, it has momentum. The amount of momentum an object has is related to both its mass and its velocity as it's moving. In football, there are momentum aspects throughout the game. At the start of a play in football, most players have no momentum. This is because the players are not moving. In football, players collide with each other. There are three types of collisions in physics: elastic, inelastic, and completely inelastic. An elastic collision is a collision in which both momentum and kinetic energy are conserved. An inelastic collision is a collision in which some kinetic energy is lost. A completely inelastic collision is a collision in which all kinetic energy is lost. The law of conservation of energy states that energy cannot be created or destroyed. This is applicable to the movement of the football after it has been thrown. When the football is released from its throw, it has kinetic energy on both the horizontal and vertical plane, while it has only potential energy on the vertical plane. Let's look at the football's vertical travel. When the ball is released, it has both kinetic and gravitational potential energy. When the ball reaches its maximum height, the ball has transferred all kinetic energy into gravitational potential energy, meaning it has no vertical kinetic energy. Then the ball starts to travel back downwards towards the ground. This is when the gravitational potential transfers into kinetic.